Hello and good day. So for today, we'll be continuing the second part of our discussion about the TCP/IP suite protocol layers and the services under them. As mentioned, the TCP/IP protocol suite contains four specific layers, and each layer has its own set of protocols and services available to them. Now, one of the most important protocol that is used in networking is ICMP. And ICMP, as mentioned, stands for Internet Control Management Protocol. This is quite important as most of network troubleshooting tools or the basic troubleshooting tools that can be used on a network is available through ICMP. So for today's discussion, we'll look at some of the basic ICMP instructions or networking tools that could be used as your basic troubleshooting step. So first and foremost, we'll be looking into IPconfig or IP configuration tool. So the IP configuration tool is used to get a general overview of the landscape of your desktop or your device and how it is connected to your network. So it would provide you some basic information. For instance, it would be giving you the IP address in version 6 and version 4, subnet masks, and the default gateway. So we could use this command to verify a network connection as well as to verify certain network settings. So let's take a look and have a demonstration of how we would be able to command IPconfig. Now, before I forget, IPconfig and most of the networking tools or all of the networking tools we will be mentioning here will be done using the CMD command. So I have already invoked the CMD command here. So in order to config or to manifest IP configuration tool, we just type in IPconfig. And once we type in IPconfig, we will be seeing lots of devices connected to us. But the one that we're most after would be the Ethernet adapter, okay? The one that we are primarily connected to. So it will be showing us our IP version 6 and IP version 4 address. Now, we have discussed the value of the subnet mask. We use the subnet mask to be able to, for the devices to be able to separate the network ID from the host ID. And from the subnet mask, we would be able to determine that, of course, our IP address is in version 4. As we have 3 octets of 255s and 1 octet of 0. The 255 represents an octet of 1s, so that would be 3 octets of 1s. Next, we have ping. Ping stands for packet or packet internet groper. So this is oftentimes used to determine or to verify the quality of our connection to the network, to a specific host, to a specific device or node, and even our connection to the internet. So it uses the ICMP echo message. ICMP echo message is a packet sent to a specific node in which the node, when it receives an ICMP echo message, would reply back as an acknowledgement. Now, this is once the node sends back a message, the receiver or the original sender would be using the statistics of how long it takes for the receiver or the node to answer back as a means to test the quality of the connection. So we could actually see several things from doing ping. So let's do a demonstration of ping first before we look into the individual contents of a ping. So if we do a ping, we just type in ping. Okay. It would first show you the available attributes or options we have for pings. Okay. For now, it is beyond our scope for now to explain each and every options available for ping. In order to do a ping, you need to put in the command ping and the IP address or the website you are trying to check the connection to. So let's say I'm pinging facebook.com. Okay. So more or less, the default setting for ping is it would send 32 bytes of data 4 times. And it would check the response time and how well the bytes that was sent has been able to receive. Now, when we do the ping, instead of seeing facebook.com, you'll be able to see an IP address. So this 157.240.13.35 is just one of the IP addresses used by Facebook. As we can remember, when packets and data is sent through the internet, it doesn't really use the address or the URL. It has to be translated into its IP address through the use of a DNS server. So in this case, the facebook.com was looked into the DNS server, and I'm assuming the closest one that we have would be the 157.240.13.35, or at least that's the one assigned to our location. It would also show you the number of bytes that was sent and received, the time it take for the ping to echo or to be sent back. For instance, the 60 milliseconds means after sending the first 32 bytes, I was able to receive an acknowledgement or a reply 60 milliseconds after. TTL means time to live. This is, or time to live in some text. This shows how long the ping would actually wait, or the packet would actually wait. If the time exceeds the amount of the time to live, or the TTL, it would actually get lost. Now, there would be a summary at the bottom showing the number of packets sent and the number of packets received. Now, from our demonstration, we were able to see that we actually have 4 packets sent and 4 packets received. So that would be 100% recovery rate, or 0% loss. So if for some instance 2 packets were lost, we would be seeing sent 4, received 2, and a loss of 50%. We would also be seeing the maximum and minimum trip times or round trip times in milliseconds, and also the average trip of all 4 packets. Now, as the ping was successful, as it was able to see the web server, it actually answered back. But there are some instances that this would not be true. So what are the other possible replies that we can see or we can receive from a ping? So we could have a ping request could not find host. So that would mean that the web address that we typed in is non-existing. So it's either we misspelled the web address, or the web address doesn't really exist. Now, if the website and web server has been located, you would be receiving a reply from. When we receive a request timeout, that means that the web server or the address has been located, but it isn't responding to ping requests. So there are web servers that doesn't respond to ping requests, as ping or pings could be a signal or a precursor to a distributed denial of service. So some web address or web servers do not respond to a simple ping. TTL, expired in transit, means time to live. Expired in transit, it means that the packet in the network exceeded the number of hops. Hops being the number of jumps it takes from node to node up until it reaches its destination. We have to remember when we connect to a web server, it is quite rare to see that we can have a direct connection. It's almost impossible. It's almost always there's an intermediary node in between my gateway or my router and my computer to a web server. So there are nodes. Now, if the web server's location is quite far geographically or even in a network, it could be also true that it could be geographically near, but many nodes are needed to be able to connect to that specific network. That could also lead to a TTL expired in transit. Next, destination host unreachable. So this is different from ping request could not find host and request timeout. So what's the main difference? In ping request could not find host, the host that you're trying to ping or the web address you're trying to ping does not exist. In request timeout, it exists, it was found, they received the ping, but they did not answer back. In destination host unreachable, the address is existing, but the ping or the packets could not be received. Either the website is down or the network where the address or the network where the web server or the receiver or the host that you're trying to ping is located is actually not reachable at this point. Well, the router knows it exists, but it cannot reach it. So, hence, destination host unreachable. So, please take note of the differences of those return responses. Now, talking about hops, if we want to actually take a look into a more detailed route or summary of the route it takes, instead of doing a ping, we do a trace RT or trace route. So we use this to view how a packet actually arrives at a specific destination and what routes and what specific nodes it would travel to before it reaches its final destination. Sometimes this is used to check on some problem areas where the packet is having problems. Sometimes when we send or download data, large amount of data, even though our internet speed might be fast, we're downloading at a slow rate. That means there might be a bottleneck somewhere in between the hops. It might be at the destination, it might be near our source, or it might be somewhere in the nodes. So one thing we could do is use traceroute to check it out. So let's do a demonstration of traceroute. We're still going to traceroute facebook.com. Let's see how many hops it takes before it reaches the server. So you'll notice that the ping I'm sorry, not the ping, but the IP address actually changed. It has the first two octets are the same, but the last two are different. Again, big web servers or big companies have multiple IP addresses to hold their web servers. Okay, so we're up to 4 hops now. You can see that the second hop has a request timed out. Okay. So it means that the second hop did not respond to the trace route. What happens is that the packet travels from node to node. Unlike the ping, where only the last or the host that we're trying to ping is the one that is required to answer back. But for this, each node that it passes through would be asked to actually answer back. And it would give us the statistics of its travel from its location to our source here. So the trace route is finished, and we can see that there are 10 hops to actually reach the web address of facebook.com near our location. So what are the meaning of this tree? So Let's take a look first at the other messages that we could receive aside from trace a request timeout. So request timeout, as mentioned, this means that the node received the packet but did not answer back to our requests. When we have a complete address, that means that it was reachable and they were able to answer back. Now, if for some instance we tried doing a trace route on a web address that doesn't exist, it would actually give us an unable to resolve target system. So this is analogous to ping request could not find host, or the host does not exist. Once the trace is complete, it will show you us trace complete from source to destination. The last hop would be the last IP address of the web server. Destination network unreachable means that the website exists, but it's either down or doesn't, or the routers or the devices doesn't know how to reach the system. It's in a network that is unreachable. So this is same as destination host unreachable in ping. Yeah. Now there is a maximum amount of hops that could be done with traceroute. So if the web address or IP address or host you're trying to reach is over 30 hops long, then it might have a problem with traceroute. Some systems and protocols could only handle up to less or than 30 hops. Another important thing that we could use to determine if our network has been compromised, like a virus, a worm, or Trojan, is actually using our computer to actually send out or use a network to send out bits and pieces of um, things. No, for example, our computer has been used as a zombie network to be used in a DDoS. We use Netstat. So Netstats actually shows us the available connections and the port numbers it's using, its state, and so on. So it covers both IP, ICMP, TCP, and UDP protocols, and works for both IP version 4 and IP version 6. So let's try doing a netstat. Okay, let's wait for it. So right now I have two active connections. Both are TCP. Okay, they're using my local IP address, and we have two foreign addresses where it is connected to, and its states. Okay. Let's try -NA. So -NA is a more complete version, which shows, because this one shows the active connection, but if you want to look at all connections that are waiting, in this case listening, and others that are off, like the TCP and UDP, like in the ones here, then we use -NA. So what are the meaning of the states here? For those that are active, established, and waiting, it actually shows a foreign address where it is connected to. But for those that are listening, it doesn't have yet a foreign address, as it's still waiting for an event before it is able to connect. So close means that the connection is active or pending, or no connection is active or pending rather. So the connection between the two is actually close. If it's listen or listening, so it is not active, but it's not yet closed. It's waiting for something before it becomes active or it becomes closed. Sync receive and sync send. Okay? So this is used for establishing a connection with a specific foreign address that has started from listening into active. If it's established, that means the current system or current connection is active and it's transferring at a normal data transfer rate. Now, once the active state has been done and the connections needs to be severed, they send a finish wait 1 and finish wait 2. Finish wait 1 means the client has confirmed it is finished. Finish wait 2, server has agreed to release. And afterwards, it would go to closing or close wait. Then eventually it would return to closed. If it's waiting for pending packets, sometimes the source or the destination would not be sending additional packets or would not be accepting additional packets while it's in the waiting state, as that means that it's waiting for an acknowledgement. And last acknowledgement is waiting for pending packets as well. Now, there are many syntax or options that we could use for Netstat. So what we use is the -an, but I use -na because I want to look at active connections and listening ports. If I just put in Netstat, it would just show us all active connections. Those that are waiting for an event before becoming active has to have an. If we use -a, active connection and listening ports. Okay. The main difference with n is that it's using the list uses IP address, a uses the full domain name. Okay. So there are actually much more network or Netstat syntaxes available, which is just a combination of A, N, and O, E, and P. Okay. And we could use this if we have an understanding of the legitimate connections to the network from our system's perspective. We could root out possible intrusions on our system, as we would be able to see listening states or listening connections or ports that are trying to listen or waiting for a connection that should not be there. Once you're used to what you're supposed to see in Netstat, you'll be able to actually verify which connections are legitimate and which connections are dubious. Anyway, as always, if you have any corrections or any questions, feel free to message me. And as always, we'll have a last lecture or the last discussion about routing next week. Okay? So we'll try to, I don't know if we're going to have a two-part series for that lecture, but if we do have a two-part series, that would be the last two for this semester. Anyway, as always, please stay safe and take care.